Hello everyone, welcome back to this channel. In this video we are going to continue with method of undetermined coefficients. In the previous video we started with this method and we saw that the homogeneous linear differential equations have two components in their general solutions, yc and yp, and yp is obtained through method of undetermined coefficients after setting up the trial or the guess yp and then finding the undetermined coefficients depending on the equation given. Now in this video we are going to continue with that method. In the previous video we had discussed simple situation only, where the normal trial yp, the simple trial yp which we had listed in a tabulated form there, those yp's were working well, but here we'll come across situations where those simple yp's will not be working, and why they'll not be working and what to do in those cases is the intention of this video. So let's start with a motivation, a problem where the trial yp, the simple trial yp is not going to work, and how do we modify it, that will be clear in a little while. So let's consider this differential equation y double dash minus y equal to e to power x. You can see that it's a non-homogeneous linear differential equation. So our solution will have two components, y equal to yc plus yp, where yc is the solution of the associated homogeneous equation, and associated homogeneous equation in this case will be y double dash minus y equal to 0, and hence the characteristic equation will have two roots plus minus 1, and this will be your yc because they are real and distinct roots. So the contribution of 1 will be c1 e to power x, and minus 1 will contribute as c2 e to power minus x in the complementary function of this equation. Now moving on to yp through method of undetermined coefficients. If you remember, in the previous video we learned that if the right hand side is an exponential, then we try a constant times the exponential itself as a trial yp. So let's try doing that here also. When we do that, yp, suppose we try yp as a e to power x, what will happen? What will be y dash? Yp dash will be a e to power x only, and yp double dash will be a e to power x. So when we substitute here in the given equation, it becomes a e to power x minus a e to power x is equal to e to power x, which lands into 0 equal to e to power x. So that means this trial yp a e to power x is not working here, and the method of undetermined coefficients will fail to apply in the equation here if we assume our trial yp to be a simple a e to power x. Now why is this happening, and why and how do we modify our trial yp? Now let's go into that. Let's go into the why part first. Now why it is happening will be clear. I've listed the special situations here in a tabulated form for you to understand it better. Now the simple cases which we had discussed in the previous video had no complication. We were just trying normal trial yp and everything was working well. The coefficients were easily obtained through substitution in the given equation because these two were not happening. What are the two special situations where simple table is not going to work? Number one, the first simple situation is that when r equal to 0 happens to be a root of the characteristic equation, then you need to modify your trial yp. How? I'll come to that in a little while. And the second situation is that suppose there is a root of the characteristic equation which corresponds to a term on the right hand side. Now what do we mean by that? Now suppose r equal to 1 is a root, let's say, okay. So r equal to 1 is a root of the characteristic equation and the right hand side already has e to power x. For example, in the question above, y double dash minus y equal to e to power x, we saw that r equal to plus and minus 1, they were the roots of the characteristic equation. Now 1 is a root of the characteristic equation and 1 corresponds to, we know, e to power x, right? 1 corresponds to, in yc it corresponds to e to power x, and e to power x happens to be appearing on the right hand side also. So this becomes a special case. So the special case arises in two situations. Number one, if r equal to 0 is a root, or there is a root, say r1 of the characteristic equation which corresponds to a term on the right hand side also. In those two situations you will not be considering the normal trial yp. What you will do is, suppose r equal to 0 is a root, then instead of taking the normal trial yp, we will have to consider the terms arising out of integration of that normal trial yp. How many times? K times, if the root is appearing k times. If 0 is a root of the characteristic equation appearing k times, then instead of normal trial yp, you will consider the terms which arise out of its integration done k times. You will have to look into the terms which can arise out of integration of those terms done how many times? As is the multiplicity of 0. Similarly, if there is a root of the characteristic equation with multiplicity k which corresponds to some term on the right hand side, then in this case also, instead of taking the normal trial yp, we will multiply the affected part. That means suppose there are two parts of this question. Suppose had it been e to power x plus, let's say, sine x, then sine x does not correspond to +1 or -1, but e to power x does. So for sine x you will do the normal trial yp only, but for e to power x you will modify your trial yp by multiplying the affected part by x to the power as is the multiplicity of that root, and then write the corresponding trial yp. And in the end you will also consider the terms arising out of, possible terms which can arise out of differentiating the terms that you have got in the modified trial yp. So what do we mean by that? Let me demonstrate in this example first. Going back to the question which we started with, here e to power x was the right hand side and r equal to 1 was a root of the characteristic equation. So that means e to power x has an appearance in yc also. So if that is the situation, that there is a root of the characteristic equation, that means there is a contribution in yc component already, then for the yp component, the affected part, that means the root, suppose the root is 1 corresponds to e to power x. So e to power x on the right hand side is the affected part here. Alright, so instead of e to power x, you will take x to the power as is the multiplicity of the root. The root has multiplicity 1 here. R equal to 1 is coming once. So instead of e to power x, you will consider the trial yp for x e to power x. Alright, so how do you modify it? Your modified trial yp will be, instead of e to power x, you will not write the trial yp for e to power x, you will write it for x e to power x. Now what is the trial yp for x e to power x? It will be ax plus b for the x part and some constant times e to power x. So what kind of terms are arising? A into c, which is a constant times xex type term which I have already taken, and a constant times e to power x term. Now why did I not write a constant times e to power x term? Because that kind of a term is already coming in yc. So this can be avoided, because in the end your answer is going to look like yc plus yp. So if there is a term in yp which is already existing in yc, then you can ignore that term. That will ease out your calculus. Even if you don't ignore that term, in the end nothing will be wrong, but it will be unnecessary. You can always avoid writing the terms in your yp which have already made an appearance in yc, because in the end you are going to do yc plus yp, so it will not matter. So that is the reason the trial yp, which was a e to power x from the original table, was not working, because e to power x already had an appearance in the yc component and it was corresponding to the root r equal to 1 which had multiplicity 1. So according to the rule, special case, second part, r equal to 1 was appearing in the differential equation with multiplicity 1. So in this case, we modify our trial yp by multiplying the affected part by x to the power 1 and also considering the terms arising out of its differentiation. Also, the terms that already appear in yc should be removed from trial yp to ease out calculations, because there will be unnecessary constants involved in the trial yp if you do not do that. Alright, so let's go back to this sample question which we started with. Instead of x e to power x plus b e to power x, first of all it had to had a b e to power x, which we did not write because b e to power x kind of a term was already coming in yc. So we will not write duplicated terms from yc. So your modified trial yp will be this. I also told you that you have to consider the terms arising out of differentiation of your modified trial yp also. Now when you differentiate x e to power x type term, product rule will be applied. So you'll have an x e to power x term or an e to power x term also again. But e to power x kind of term is already there in yc. So you do not get any new terms when you differentiate this expression also. So that means your modified trial yp will have a single term ax e to power x, and when you differentiate you find out yp dash, you find out yp double dash, substitute in the equation, you get your a to be half, and therefore your modified trial yp which you had taken as ax e to power x turns out to be half x e to power x in this calculation through the substitution in the differential equation. So once you get your modified trial yp in order, the answer is y is yc plus yp. So that's the story of special situation. I am repeating that there are two special cases when you need to modify your simple trial yp's. The first is if r equal to 0 is a root. The second is if there is a root of the characteristic equation which is corresponding to a term on the right hand side. Now if r equal to 0 is a root, then instead of normal trial yp, you will take the terms which arise out of its integration done as many times as is 0 the root. The second special case is that if r equal to r1 is a root of the characteristic equation which is say having multiplicity k, then the affected part, the term which is corresponding to that root, will not be written as normal trial yp. You will modify that component by multiplying that affected term with x to the power k, where k is the multiplicity of the root which is the affected root. Alright, so in this case you take normal trial yp and then integrate it k times and then see what kind of terms are arising. You have to consider those also, and in this situation you have to multiply the affected part by x to the power k and then also consider the terms arising out of differentiation of those terms. Now also keep in mind that the redundant terms, the terms which are already there in yc, they are already appearing in yc, they can be ignored in yp so that you have easier calculation. So we have listed a lot of problems here for you to understand the non-normal or the special situations better. So I'll take them up one by one. For example, your question is y3, so that means y triple dash plus y dash is 2 minus sin x. So its characteristic equation will be r cube plus r equal to 0. So that means r is 0 and r square plus 1 is 0. Alright, so because r is common, r square plus 1. So the roots are r equal to 0 and plus minus iota. Now 0, as soon as you get a 0 in the characteristic equation, it activates your special case 1. R equal to 0 appearing in the initial equation with multiplicity k, then you have to integrate the normal trial yp k times. So that means if r equal to 0, what would be the normal trial yp? For this term 2, it would be just a, and for sin x, it will be b sin x plus c cos x. From the previous video, we know this, alright. So it will be a plus b sin x plus c cos x. That would be your normal trial yp, but this normal trial yp would not be working here because 0 is coming as a root. So instead of taking this yp, you have to consider the terms which arise out of integration of this expression done how many times? 0 is coming once, so you will integrate once. When you integrate a constant once, you get a term like ax, alright, and then its differentiation also. So you'll get terms of the type ax plus b from this component. That's the modification when I am applying 0 as the special case. Now what kind of terms will arise? If I integrate sin x, I am going to get a cos x type term. If I integrate cos x, I am going to get a sin x type term, and the derivatives will also be sin x cosine x type. So I'll have c sin x e cos x type terms after applying 0 rule to this, because 0 says that you have to consider the terms arising out of the integration of the normal trial yp done once, because 0 is appearing once, and then also look for terms if there are any new terms arising out of its differentiation. No, because ax ka differentiation is going to give a constant ka differentiation is going to give a 0, sin x ka is going to give cos x ka is going to give sin x. So that means you do not get any new terms, you have applied the 0 rule. So 0 rule is done. Now let's look at plus minus iota. Are they important? Yes, they are important because they are affecting sin x. What will be your yc? Yc will be c1. Because of 0, it will be just c1, and because of plus minus iota, it will be c1, a constant times cos x plus another constant times sin x. That is your yc. Now, is there a root of the characteristic equation which corresponds to something on the right hand side? The right hand side is 2 minus sin x. Plus minus iota is a root which corresponds to sin x, because sin x comes in yc component because plus minus iota is a complex pair. So that means this is an affected term. Sin x is an affected term, affected by this complex pair appearing once. So instead of sin x, you will have to multiply sin x with x and then consider its normal trial yp. Normal trial yp will not work here. Instead of normal trial yp, you will have to multiply this sin x with x to the power 1 because it's a complex pair coming once, and similarly multiply this cos x with x to power 1 because plus minus iota corresponds to sin x on the right hand side. So instead of normal trial yp for sin x, you will write for x sin x, which is cx sin x plus ex cos x, and after differentiating these terms you will either get x sin x type terms, x cos x type terms, sin x type terms, or cos x type terms, which are already appearing in yc, so you don't have to bother about them. Now here also b is extra because b kind of a constant kind of term is already in yc, so you can ignore that. So effectively the only terms which are not overlapping with yc, and after applying both the rules, the 0 rule and the plus minus iota rule, the special root r equal to r1 wala, the second rule, after applying both the rules, you can apply them in any order. You can first consider plus minus iota and then apply the 0 rule, or first apply the 0 rule and then apply plus minus iota rule. Effectively, the only new terms that you're going to get in your trial yp will look like a constant times x, a constant times x sin x, a constant times x cos x. So this is your effective, the most optimized trial yp after applying both the rules and also getting rid of the terms which are already appearing in yc. So that is how you modify your trial yp, and if you do not modify it, you can try the normal trial yp which you learnt in the previous video. The things are not going to work. This process which we have been adopting for doing method of undetermined coefficients is going to fail if you just take the normal trial yp. But why to do that? You should be clear in advance. Looking at the roots of the characteristic equations, you should activate your rule special case 1 or special case 2 looking at the situations. If r equal to 0 is a root, then integration rule is activated, and if r equal to r1 is a root and there is a term corresponding to that r1 on the right hand side, then rule 2 is also activated. So let's look at the second example. The second example is, if you look at the characteristic equation, it will be r cube minus 1 equal to 0. So that means r is 1. These are cube roots of unity. So 1 omega squared. These are complex numbers and this is the only real root. Now look at the right. So 0 is not coming as a root of the characteristic equation. So special case 1 is not activated. Let's see if special case 2 is activated here or not. R equal to 1 is a root. Omega and omega square are complex numbers. There's nothing with e to power x sin x or e to power x cos x type of terms are not appearing. Alpha beta. So if this is alpha plus minus iota beta, then e to power alpha x cos beta x or e to power alpha x sin beta x type of terms are not appearing on the right hand side. So that means these roots are simple roots. They are not affecting any term on the right hand side. But 1 is affecting. This root 1 affects the term e to power x. It's not affecting 7, but it's affecting e to power x. So for e to the power x, you will not write the simple trial yp. What was the simple trial yp? Let's first, if this was not a special case, then what would we write? We would write for e to power x, we would write a e to power x, and for 7 we would write b. That would have been the normal trial yp. But r equal to 1 is a root of the characteristic equation and it corresponds to e to power x. So instead of e to power x, you have to multiply the affected term with e to power x and then write the trial yp for this. So ax e to power x will have trial yp as what? Ax e to power x, b e to power x after differentiation, and for the constant 7, it's an unaffected term, so you will just have normal trial yp for this unaffected term. But since b e to power x type term will already come in yc, you do not have to write it in yp because it will be unnecessary repetition and another constant which will appear in yp, which will increase your calculations to a little amount. Alright, so you can always first apply the rule, look for possible terms which can arise out of its differentiation. There will be no new terms generally arising out of differentiation in these cases, and then remove the ones which are already appearing in yc to avoid duplication and unnecessary calculation. So the effective nature of terms which are remaining in your trial yp are ax e to power x type term and a constant type term. So this will be your trial yp for this situation. Alright. Now moving on to the third question. This is r square plus 4r equal to 0 will be your characteristic equation. So the roots are 0 and minus 4. Now once you see 0, the rule is activated. special case rule 1 is activated. So let's see, if 0 is a root, then instead of writing the trial yp for 2x, you have to integrate the trial yp how many times? Once, because 0 is coming only once. So what would be the trial yp for 2x? It will be ax plus b. But since you have to integrate ax, it will bring in x to power 2. Bx, it would have been ax plus b for the normal situation, but now it would be ax square plus bx plus c, but plus c need not be written because 0 is appearing in the characteristic equation, so you will have a pure constant already appearing in yc. So that can be, because yc will be what? C1 plus C2 e to power minus 4x in this case. So C1 type, constant type term is already appearing, so you don't have to write plus c here. Only ax square plus bx will be there. It's just special case 1, r equal to 0 is a root. Special case 2 is not applicable here, because minus 4 corresponds to e to power minus 4x, and that kind of a term is not appearing on the right hand side. Moving on, look at y5. So it's r5 minus r cube equal to 0. This is your characteristic equation. So r equal to 0, 0, 0 and r square minus 1. So 1 minus 1. These are the roots of the characteristic equation. So pay attention here. 0 coming thrice. So instead of normal trial yp, you will take the trial yp which comes after integrating the normal trial yp 3 times. Also 1 is a root and 1 corresponds to e to power x. So instead of writing for e to power x, you will write for x e to power x. Minus 1 is unaffected. There is nothing affected by minus 1 on the right hand side. So let's first apply the 1 rule. Alright. So 1 is only affecting e to power x. So instead of e to power x, you will write for x e to power x. What will be the trial yp for x e to power x? It will be ax e to power x, plus there will be a term. First let me write this. Your yc will look like this. C1x plus C2x plus C3x square e to power 0x, C4 e to power x, C5 e to power minus x. So ax e to power x plus b e to power x will come from the e to power x component, but b e to power x type term is already in yc, so we don't write it. Alright, now let's look at this. For 2x square, it will be bx square plus cx plus e, and for 5 it will be another constant, but since I have already written a constant, I don't have to write plus f, because e plus f can be combined to be written as a single constant. Now let's apply the 0 rule. 0 is coming thrice, so we need to integrate these terms thrice and then see what kind of terms are coming. When you integrate x e to power x thrice, by parts will be activated and you will not get any terms apart from x e to power x or e to power x type terms. For x square, it will become x5. When you integrate the x square term 3 times, it's going to become x5, and x5, x4, so x5 kind of term will come. Why is it hanging again? X5 kind of term will come. Wait. Yeah. X5, X4, X cube, and reduced powers will also come. But since x square, x and constant type terms are already appearing in yc, so we do not write them. So effectively you will get xex terms. Ex type term is already coming in yc, so we do not write it. Then x4 type term, x cube type term, x5 type term. So these are the terms that you get effectively in your trial yp. This is the most optimized trial yp which you can write after removing duplication from yc also and applying both the rules. Now let's look at the next problem. Here r square minus 4. So r is plus minus 2, and cos hyperbolic 2x you know is e to power 2x plus e to power minus 2x by 2. That's your right hand side. So 2 is affected. 2 affects e to power 2x with multiplicity 1. Minus 2 affects e to power minus 2x with multiplicity 1. So you multiply by x to power 1 and then take the derivatives also, but derivatives will not have anything else apart from e to power 2x and e to power minus 2x type terms which are already in yc, so you do not have to write them. So that's how you modify your trial yp's. First, look at this problem now. It's r square plus 9 equal to 0. So r is plus minus 3 iota. Now mind it, plus minus 3 iota corresponds to cos 3x and sin 3x. Such terms are not appearing on the right hand side, sir. So it's a normal situation. It's not a special situation. So you'll just write your normal trial YP. No modification has been done here. Do not think that plus minus 3 iota affects e to power 3x. No, 3 affects e to power 3x. This is e to power 3x with x square attached. So this would be affected only when 3 is a root. Plus minus 3 iota corresponds to cos 3x and sin 3x type terms which are not coming. So it's a normal trial YP which we learnt in the previous video. But if you look at r square plus 9 equal to 0, and here now cos 3x is coming. So now it is affected with multiplicity 1 because this complex pair has multiplicity 1. So instead of normal trial YP, you multiply it with x to power 1 and then take the powers, the modified trial YP. And if you look at this, again r square plus 9 equal to 0. This is intentional. I wrote these three problems together to make you understand that here e to power 3x is not affected. So write its normal trial YP. Cos 3x is affected because plus minus 3 iota corresponds to cos 3x and sin 3x. So multiplicity 1 affected by multiplicity 1, and hence the modified trial YP is this. This one is again not affected. It's not just cos 3x. It's e to power x cos 3x. So it's corresponding to 1 plus minus 3 iota. This kind of a term comes after having 1 plus minus 3 iota as a root of the characteristic equation. So this is again unaffected, so you will just write your normal trial YP. So do not think that cos 3x appearing with anything is going to be be affected by plus minus 3 iota. No, if it's coming with an exponential, then e to power x cos 3x corresponds to the complex pair alpha plus minus iota beta, where alpha is 1, beta is 3. So this term is not affected by plus minus 3 iota, it's affected by 1 plus minus 3 iota. So we did not modify our trial YP, it was a normal situation. This was affected, this was not affected. So I hope this is clear to you. Here r square plus 1 is 0. So plus minus iota will be the roots. So sin x and cos x are the affected terms. So you write the modified trial YP because plus minus iota is coming with multiplicity 1. If you look at this, this is r minus 2 whole square will be coming. So this is affected by multiplicity 2. So you write x to power 2 and then you take the reduced powers. Then they will already be appearing in YC. So this will be your normal trial YP modified and optimized in the end. Now look at the last problem listed here. It's r square plus r equal to 0. So r is 0 and minus 1. So 0 rule is also there and minus 1 is not affected. Why is minus 1 not affected? Because this corresponds to 1, not minus 1. So first write the normal trial YP for them. It will be ax plus b plus c to power x. And then since 0 is a root, you will have to integrate these terms. C to power x will not lead to any new terms, and the reduced powers will already be appearing in YC, so you do not have to bother about writing them. So that is the crux of this video, the modification of your trial YP. See, even if you do not get to know that it's a non-normal situation or a special situation and you try your normal trial YP, things are going to fail. You will not be able to calculate your undetermined coefficients, and hence you'll get to know that you did something wrong while guessing your trial YP. But that will waste a little time. So whenever you look at the characteristic equation and you see that 0 is a root or there is a root r1 which is corresponding to something on the right hand side, corresponding to a term on RHS, then the special rules will be activated. The 0 rule is that instead of normal trial YP, you will have to consider the YP terms will also be including those terms which arise out of integration of those normal terms done how many times as is the multiplicity of 0. So if 0 is coming twice, you will consider the terms which can arise out of integrating that normal trial YP twice, like that. And if there is a term on the right hand side which corresponds to a root with multiplicity say k, then instead of for that particular term, for example, if 1 is a root coming thrice and e to power x is appearing on the right hand side, so you will not write for e to power x, you will write for x cube e to power x, because 1 corresponds to e to power x and 1 is also a root of the characteristic equation. So that's how you modify your trial YPs and write the most optimized trial yp after removing duplication with yc to ease out calculations, and then apply the standard method, substitute this trial yp in your given equation and find out the undetermined coefficient. Thank you so much for watching.